Internship in Let's Grow More. So my task is based on the music recommend system. The data set provided is of KK box. So over here there is a 6 data set. So how we need to deal with it is based on the task, and the the task is based on the user based recommender system. Okay, so let's start with it. So first we'll just import all the necessary libraries. Now in doing this recommender system, I'm using the similarity based cosine similarity ones. Even you can try it with the Euclidean distance also, but if there is a high dimensional, then a little bit an error occurs. So cosine similarity will perform well in any part. In while reading this data set, in every part of the data set, like in members, submissions, songs info, in every part of the data set there is a different contents of rows. Means all the rows were not same. Means the number of rows of all the data set were not same. Okay, you can try it with it, but if you will read the complete data set, even some of the data set contains even on the lakh. Okay, the rows contains the number of rows, it contains in the terms of lakhs, like 27 lakhs, something like 2 lakhs, 10 lakhs, something like. So you can read with it, but when we are doing with the similarity ones, like when we are doing the cosine similarity ones, the problem will occur. Okay, your system will hang because of that. While doing the cosine similarity or while doing the recommender system. So I take only minimum rows, like 20,000. Even you can try it with till 50,000, it works well. I have tried with 50,000, it works well. Okay, now I just took the 20 rows, and the members song info, the test that I haven't took any rows, because you can see the data that the columns are not so important, and if it's important then I have merged in a one column and I have used it. Let's get started with it. So first I have read the members data set, in which it contains of MSNO, city, gender, okay, expiration date. In submission it contains only two column, ID, target, and a song info. So the task that we are going to perform is based on the music, right? So once the user sees one music, like any of the music, like over here one of the name is Let Me Love You. If the user sees this music, then all the recommender, like till the 10, okay, till the count of the 10, it will be recommended to the user. So this is only a basic task. So the name is nothing but a song, we will rename it. Okay, first I'll just read the data set, what all columns we have and how many rows, columns, that we need to understand it before starting with any project. So is it null values or not, that we are checking over here. You can check it on ISRC, that is lots number of null values. Basically I have read this complete data set, not the 20 rows. Okay, while reading the complete data set, it contains this. In song info I haven't used the n rows is equal to 20,000, that's why it read it completely, and you can see it how many null values it contains. This is the song in which in this song data set, all the important columns were there, like artist name, composer, lyricist, okay, song ID. This is the most important one for doing the recommender. So I have used this, that's why I have made it as 20,000, because this I'm going to over here, it's there, because I'm going to use this data set for it. And let's move to the train one. Okay, over here I have dropped all the unnecessary columns, like source system tab, source screen name, and source type, all the unnecessary column. And MSNO is nothing but a user ID, so I have replaced it. So let's start with the data pre-processing process. Okay, before starting with it, you can easily identify that in most of the dataset that we have read, almost every dataset contains the song ID, okay, or the user ID, something like. So based on that, we can merge it, right? So I have merged it based of the song ID, and the song length language, that all I have just dropped it. Okay. Name, that I previously have said that name is nothing but a song name, so I have just replaced it. Oh, here is that. So once there is a user gives the music as panda, so in all the later movies later panda will be recommended to the user. So this is a main agenda that we are going to do it. And you can directly see that there is a many number of duplicate values, like over here some duplicate values is present. So before starting with the similarity also, we need to remove this duplicate. So how we will remove it? Okay, that we can try it, but before that, we need to clean the data because it contains all the null values, right? So we need to clean it, and then after only we need to do it with similarity, etc. things. So over here we can see that all the genres ID that I have presented, that I have found this unique values, that how many values present in based on, it's all in the as in descending order. So this is the topmost genres ID 465, in which contain the count is 710. Okay, over here also you can see some slash. Okay, this marks is there, so we are going to replace it. This is nothing but for replacing only. And over here what I am doing, I'm creating one column in which it contains the club of the column, like artist name, composer, lyricist, all in the one column itself. So for that purpose I am creating one column, and then after I will drop this 3 and I will use this for recommended. So this is nothing but my user ID, which I found the value. So first it was showing that there is no null values, sorry, no duplicate. Okay, but before creating one similarity, you can directly see that it contains the duplicate values. Okay, within the first 5 rows you can see the duplicate, first 5 rows we can see the duplicate, then other also that will be definitely. So how we have removed that we are explaining. Okay, so before that I'll just create one copy file of my df with the temp df. Okay, this I'm going to use it, in which it contains around 889 duplicate values. Okay, in which the rest value will be 1059, and now the duplicate values is dropped. You can even have a check with it. You can have a check that over here it's dropped completely, right? And this now we are going to reset index in place is equal to 2. It's nothing but over here it's stored in some different index like 0, 2, 4, 21. So it would be better that if it's stored in the reset index like 0, 1, 2, 3, the default one. Okay, because we are going to do it with the help of the index. Okay, so this will matters a lot. Okay, let's start with the similarity. Now it's ready for similarity. Now we have a less number of rows. I think around like 794 rows only, after removing all the duplicate etc things. We have only 795 rows. Now it will perform well, better than before. Like if you will do it with complete rows, like we that I have said that around 27 lakh the data set contains. If you do with complete, then while doing the similarity, while performing this on itself, this not yeah, while performing this line of the code, it completely hangs. So it's better that you take a less number of data set. You can write with 50,000 perform well. Over here I have imported the TF-IDF vectorizer. Okay, so basically the TF-IDF vectorizer I have used because You can see in song details in the this is my temp df data set, okay, in which if on the particular line, for example, if I'm taking this but this line, if it contains any of the you know stop words like and is, okay, that's used in making the sentence, but there is not any meaning for that, right? So we need to remove all the things because um, while doing the similarity it's just a unwanted stuff, so we are just removing it, okay. You can check even over here after using this tf-idf vectorizer, okay, in which we need to fit perform the song test, and from the song test we are just performing the transformation in which all the unwanted stuff that we are going to remove it. Now we are performing the cosine similarity. Okay, it's nothing but doing a vector. Okay, what is the relation between the movie that we have written and the other? What is the similarity? Like over here, you can see all the diagonal elements contains the one. Okay, the reason behind it, the similarity between the first song with the first song will be all absolutely same. That's why it's giving one. The second over here, okay, this song is related, that is having a similarity with that song itself, okay. So it's that's why it's mentioned in the form of diagonal elements is one one, and other you can see some one also present in which might be the song is related to it itself or something, okay. Now there will be some points like 0.2345, like something like you can check with it because it's not showing over here. I have uh, tried it with like this part, it was showing. You can try it with it. And basically now our idea is to find the similarity which having a very less distance, like over here when we are using this, okay, this that I have said previously, you can try it with zero in row also, okay. If you will do it, then you may get in the form of like 0 point that I have previously said, okay. In which what I need to mention, like all the similarities having a very less distance, like over here based on the sorted ones I have mentioned, like first it having a 0.235 and 0.1 and then 0 0. Okay, in some of the in some of the rows, that some of the other values of the song if I will put, then the similarity will be different, okay. It's around 0.9, 0.8, 0.6. So based on the sorted ones it will give once, first it will recommend this song, then this song, then this and this, and we have given 1 to 6, that's why it's giving only 5 recommender, otherwise it may give some more than that, okay. So let's start with the recommender system. Now before starting with the recommender system, I just give a little bit thing in which based on the song index that I'm going to perform and based on the cosine similarity, the distance that I'm going to mention, okay. Based on the cosine similarity, the distance I'm going to mention, in which that I have used, that what is the meaning of this uh, line of the code that I have explained over here based on the cosine similarity. The index is mentioned. Now our main aim is that we have found the similarity, but it's based on the index. Now we need to recommend the song, okay. For that purpose I have used this. It's absolutely same, less the last line is different, and this enumerate the cosine similarity I have used in place of the distances, okay. The rest all were same. So now I have printed 1 to 10, around 9 it will be mentioned, which if the user gives panda, then all the related way, all the recommend to the user is like a content based recommend system. So the by that we have created the recommender system will recommend all for the user who have typed the panda. When you can try it with the other, like where you can copy paste it from other values also, it will recommend. So one more thing, Like only first two are having a similarity around 0.2, 0.1. Okay, that's also very less. Like we have very less number of data set, right? We have used very less number of data set. When we're using a large number of data set, even the similarity score will be higher and it will be recommended the best sort. But over here it's not as much best because we have took a very less number of rows, and only the first two are having a little bit of similarity, and the 1 2 3 are just a default ones. Okay, it's not having a similarity, it's just performing 1 2 3 4. So while I was trying with some other rows also, some 2 to some 3 to 4 it's coming the some similarity, and other some default also. But when we are trying with 50,000 rows, 60,000 rows, at that time it's the similarity score were increased, and even the best recommender you can recommend, so you can try it with some more number of rows data set also. Thank you.